Aloha BIOCHEM. This video begins Chapter 3 on Ionic Compounds, and we discuss Introduction to Bonding. So we start a new chapter now, Ionic Compounds. You can see a picture of some multivitamins right here, which provide a lot of the nutrients that your body needs on a daily basis. And this one includes calcium and phosphorus, which are two of the major minerals that are important for healthy teeth and bones. And the calcium and phosphorus in here comes in the form of calcium phosphate, which is an ionic compound. Interestingly, if you look at the nutritional label, you'll see it's called tricalcium phosphate. Now that tri prefix isn't actually needed, and in a couple of videos from now when we discuss naming, you'll see why. Let's put ionic compounds in their place and recall that they are one of the two types of compound pure substances. So hopefully this diagram looks kind of familiar. We went through a similar one in Chapter 1 when we categorized matter by composition. And recall that matter, most of it we'll see in the form of a mixture. Very rarely do you come across a pure substances. If you take dirt, for example, and you take a walk outside, you scoop up a pile of dirt, there are probably hundreds of different substances in the dirt. And mixtures, we'll talk more about them in Chapter 8. Let's recall that mixtures are when you have two or more substances that are combined in variable proportions. So a simple example would be that salt water that we discussed before. There can be lots of salt or a little bit of salt, and the proportions of salt to water can be adjusted to whatever you wish. So there are two categories of mixtures, and we'll elaborate more on them in Chapter 8. Now, pure substances are rather rare, but you can find them, especially if you purify matter. You can get to a pure substance. And there are two categories, the elemental substances and the compound substances. We discussed elements in Chapter 2, and there are various ways to categorize the elements, but one of the ways we mentioned is by the particles from which they're composed. Elements, there are atomic elements and molecular elements. I'll remind you that molecular elements, there are just a few of those. The rest of the elements are atomic. So let's recall what the molecular elements are, and perhaps you remember this diagram right here. Hydrogen comes in the form of molecules. Single atoms of hydrogen are unstable, and they like to latch on to other atoms of hydrogen to form molecules. They like to bond to each other. Okay, nitrogen does that too, oxygen, and there are several molecular elements that are listed here in this table. I think there are 10 of them. Okay, the purple and the green ones, and then all the gray ones, those are the atomic elements, where their particles are just individual atoms. So helium, helium atoms have no tendency to bond to other helium atoms. They are fine just as single atoms. And gold and sodium, those are also atomic elements. So the formulas for atomic elements are simpler. Molecular elements, their formulas have numbers to indicate how many atoms per molecule there are. Now, like elements can be divided into categories based on their particles that they're made of, compounds can too. And we can talk about ionic compounds, which are made of ions, and covalent compounds, which are made of molecules. So we'll get more into ions and the molecules of covalent compounds soon enough, but let's first recall that compounds are when you have two or more elements that are combined in fixed proportions. The definition looks similar to that of a mixture, but here compounds are made of two or more elements and the proportions are fixed. So if you take water, for instance, the formula is H2O. It's a covalent compound, and you've probably heard of water molecules. But the ratio is always 2 atoms of hydrogen to every 1 atom of oxygen. The ratio of hydrogen element to oxygen element is fixed. 2 hydrogens for every 1 oxygen. It's always a 2-to-1 ratio, so fixed proportions. And another compound substance, an ionic compound, is sodium chloride. And here the proportions are just 1-to-1. For every 1 sodium, you have 1 chlorine. And I've listed several other formulas for different compounds. And the ionic compound substances are kind of easy to identify. You will always see a metal, so sodium, chlorine, chloride, magnesium, iodide, potassium, and this is called nitrate. Whenever you see NO3, that's nitrate, so potassium nitrate. Okay, so ionic compounds, you'll see a metal and a nonmetal, but covalent compounds, it's just nonmetals. All right. Ionic compounds also have a very nice structure, okay, and I'll show you a picture of an ionic compound. So this is a picture in your textbook. So here's the substance sodium chloride. So here's a crystal of salt that you could see under a microscope. But if you had, the sodiums and the chlorines are too small to see, but if you could see them, maybe with an atomic force microscope, an electron microscopy or something, you could see that the sodium and chlorine particles have this nice arrangement. It's a very ordered structure. Okay, so sodium chloride comes from the elements sodium and chlorine. Sodium is an atomic element and chlorine is a molecular element. Okay, but they combine in the proportions 1-to-1, so 1 sodium for every 1 chlorine, to form this nice compound, sodium chloride. Now, ionic compounds are made of particles called ions, and covalent compounds are made of particles called molecules. Now, we did just mention molecules when we discussed the molecular elements, but let's talk about what they are in a little bit more detail. What distinguishes ionic compounds and covalent compounds is not only the particles that they're made of, but the type of bonding that holds the elements together. You see, ionic compounds holds the elements together through what's called ionic bonding, and covalent compounds holds them together through covalent bonding. And so let's discuss these two types of bondings here, which distinguish the different categories of compounds. And so before we do that, just let's read through this bonding principle. It'll help us understand what we're about to do. The bonding principle says, in bonding, atoms gain, lose, or share electrons to attain the same number of electrons as the noble gas atoms. Okay, so what this is saying is that to bond together, for elements to bond together, the atoms of those elements will gain, lose, or share electrons. And as they do that, the reason they're doing that is to try and attain the same number of electrons as the noble gas atoms. There's something about the noble gases that atoms want to be like. So I'll show you the periodic table. The noble gases are on the last column, okay, look at the numbers of electrons that they have. Helium atoms have 2 electrons, neon has 10, argon has 18. There's something special about having those numbers of electrons. And so what other atoms like to do is they want to try to change their numbers of electrons in order to have the same number as the noble gas has. Other atoms say, wow, I want to be like that noble gas atom, so I'm going to maybe gain an electron. That'll make me be like neon. Or maybe all I have to do is lose a couple of electrons, and that'll make me like the element argon. Or maybe I can share electrons with another atom, and that will let me be like one of the noble gases. And so that's what this bonding principle is kind of saying. I think we'll better understand it by looking at a couple of examples. So first, let's discuss ionic bonds, which hold the elements together in ionic compounds. So ionic bonds are when electrons are transferred from one atom to another. And ionic bonds, in holding together ionic compounds, they're really holding together the metals and the nonmetals. They connect metal and nonmetal, okay? And electrons are transferred. What happens is the metals lose electrons and the nonmetals gain electrons. So electrons are transferred by one of them losing and the other one gaining, okay? So let's look at sodium chloride. Okay, here you have the formula for an ionic compound. You have your metal and nonmetal, sodium chloride. The ratio is 1 to 1. Okay, 1 sodium for every chlorine. Now, let's look at the electron dot structure of sodium and chlorine separately. Sodium atoms have 1 valence electron because it's in group 1a. Let's find sodium on the periodic table. It's group 1a, so go over there to the left. So there's sodium right there, okay? And all elements in group 1a have 1 valence electron, okay? 1 valence electron. Now sodium might be element number 11, and it has 11 electrons total, but one of them is the valence electron, and so it gets 1 dot. Now chlorine is element 17. Let's go find chlorine. It's at near the end of the 3rd row, the 3rd period. So there's chlorine right there. It's element 17, so it has 17 electrons total, but 7 of them are outer valence electrons, and you can see that from its group number. It's group number 7a. Okay, so 7 valence electrons, chlorine gets 7 dots. Now what happens in the ionic bond between sodium and chlorine is the sodium metal will lose its one and only valence electron, and it'll give it all the way over to chlorine, so chlorine gains it. So sodium loses its electron and chlorine gains that electron. Now when sodium loses its electron, it now only has 10 electrons, and that is the same number of electrons as neon. So neon is a noble gas with 10 electrons. So you see, sodium, in losing its electron, became like neon. So you see that bonding principle at work? Atoms gain, lose, or share electrons to attain the same number of electrons as the noble gas atoms. So sodium lost one, and that made it like neon. Now when it lost that negative electron, it's missing a negative charge now, so the rest of what's left over is positive. And we say that sodium is a positive charged ion, or a cation. Okay, now when chlorine gains sodium's electron, it went from 17 electrons to 18. So chlorine atoms start with 17 electrons, 7 of them are valence, but after it gains sodium's, you can write it right there. Okay, now it has 18, and that makes it like the noble gas argon, and you can see argon is right below neon. It's a noble gas with 18 electrons. So you see the bonding principle at work for chlorine as well. And now chlorine is negative because it has an extra negative charge, so it's a negative ion, an anion. So the metals form positive cations, the nonmetals form negative anions. And now we know that opposite charges attract, and that's what holds sodium and chlorine together. Is now, in the compound, the sodium is in the form of positive ions and the chlorine negative ions, and opposite charges attract, and that's what holds sodium chloride together. So let's take one more look at that, salt structure. So here is that sodium chloride salt. These are all positive sodium ions, and those are all negative chloride ions. And so, you have a bunch of opposite charges just kind of all holding the whole salt together. Opposite charges, attract. And so that's what ionic bonding is cations and anions, charged species holding together. Okay. So here's what covalent compounds do. So ionic compounds, electrons are transferred, resulting in ions. Covalent compounds, electrons are shared. And covalent compounds connect nonmetals to other nonmetals. I'll remind you, all of these formulas for the covalent compounds, you see just nonmetals in here. Okay, water, ethanol, propane, these are all just nonmetals in these substances. Here is the formula for a very simple covalent compound called hydrogen chloride. The ratio is also 1:1, one hydrogen atom for every one chlorine atom. Now let's look at these dot structures separately. Hydrogen is in group 1A, so it has one valence electron. In fact, one electron total. It is its valence electron. Chlorine, we already saw, is in group 7A, so 7 valence electrons, and it's element number 17. Now what happens this time is the electrons are not transferred from one to the other, but they're rather shared. Hydrogen says, hey, chlorine, would you like to share my electron? And chlorine says the same thing. Yeah, I'll let you share my electron too. And what happens is these two electrons, one from each atom, they get positioned between the two atoms. There they are. And then you have hydrogen it's kind of like hydrogen now has 2 electrons because chlorine is now right next to it. So hydrogen, by sharing chlorine's electrons, becomes like the noble gas helium, which is element number 2. And chlorine, by sharing hydrogen's electron, becomes like the noble gas argon again. Okay? So this is the dot structure for a molecule. Okay? Now, covalent compounds, the atoms are held together by this covalent bond. That's a covalent bond. So what you have here is hydrogen holding on to that pair and chlorine holding on to that pair. When you have 2 atoms holding on to the same pair of electrons, those 2 atoms are linked. So a covalent bond is a sharing of a pair of electrons by both atoms. So they're both holding on to the same pair. Okay, you see the difference now? let's take a look at one more example. And for this one, I'll blow it up here so we can see it a little bit better. There it is. Okay, I have 3 examples here. We're just going to talk about 2 of them. Let's look at the substance water and the substance magnesium iodide. So we've already seen these formulas. Water is a covalent compound, so we're going to look at a water molecule. And then magnesium iodide is an ionic compound, and this time the ratio is 1:2. Okay, so water and magnesium iodide. We'll save propane for chapter 4. This is a little bit more advanced, but when we get into covalent compounds in chapter 4, we'll take a look at this again. So first, water. Now the formula for water is H2O. So you have 2 hydrogen atoms and 1 oxygen atom. Hydrogens are being in group 1A, they have 1 dot, and oxygen is in group 6A, so it gets 6 dots. All right, and what happens is the oxygen has a single unpaired electron here, and it is willing to share that, and so is hydrogen. And so they both share their electron, and these 2 electrons get positions between the 2 atoms, and they form a covalent bond. And this oxygen is holding on to that pair, and this hydrogen is holding on to that pair. Okay? And then oxygen does that on the other side with its other single unpaired electron with another hydrogen atom, and so you have another covalent bond over there. So you see, by oxygen gaining 2 electrons, you see it started with just these, but with this hydrogen sharing its 1 and another hydrogen sharing its 1, oxygen, it's kind of like it got 2 more electrons. And when oxygen gets 2 more electrons, it becomes like the noble gas neon. So I'll show you, oxygen is right there, element number 8. So it has 8 electrons total, but 6 of them are valence electrons. So only the valence electrons are shown in the dot structure, but 8 electrons total. And by sharing with the other hydrogens, it's like it gained more, and now it has 2 more, like the noble gas neon. Okay, and now hydrogen, by getting to grab onto those 2, gets to share those 2 as well. It becomes like the noble gas helium with 2. Okay, and so that's the dot structure for a water molecule right there. And you've probably seen the ball and stick model and the space filling model. All right, now the last example that we'll look at is magnesium iodide. MgI2 is the formula. So magnesium iodide, first the atoms. So magnesium is in group 2A. 2A, so I'll show you magnesium. It's over on the left side. It's a metal. So there it is in group 2A. It's element number 12 in group 2A. So it has 12 electrons. 2 of them are valence electrons. And so magnesium gets 2 dots. Iodine is in the same column as chlorine. So that's group 7A. Iodine is way down here in the 5th period, but it's in the halogen column, group 7A. So 7 valence electrons. How many electrons total, though? It's element 53. So iodine has 53 electrons. 7 of them are valence electrons. So iodine gets 7 dots. Now this is between a metal and a nonmetal. So metals like to lose their electrons, and nonmetals like to gain electrons. And in ionic bonding, the electrons are transferred completely. So this electron goes over here, and that electron goes over there to another iodine, and now magnesium is missing its 2 valence electrons. So it becomes a +2 charged cation, and each iodine gained one electron, they both become -1 charged anions. Now, when atoms gain electrons, they become a little bit bigger. So negative ions are a little bit larger than their atoms. And that's because the positive nucleus isn't able to pull in the negative electron cloud as much. When you have more electrons, that positive nucleus cannot draw them in as much. Here, when you have less electrons, it's able to draw them in closer. And the opposite effect occurs for cations. They become smaller than their atoms. So, the magnesium, before it lost a couple of electrons, you had this, it had a certain size. And after it lost a couple of electrons, its electron cloud had less electrons. So that positive nucleus is able to draw in that electron cloud closer. And so positive cations are a little bit smaller. Positive nucleus can draw in the electron cloud closer. And so here's that nice, beautiful structure of an ionic compound. Ionic compounds are usually solids, and their structures are quite beautiful. You see, covalent compounds are made of molecules. So this is a water molecule. It would be incorrect to say that there are molecules in here. Even if you just find, you cannot say these three, this Mg and I2, you can't say that's a molecule and that's another one and that's another one. Because somebody else might come along and say, well, what about, maybe it's that one, this one, and that one. Maybe that's the molecule. Well, they'd both be wrong. There are no molecules here. There are just charged ions. That's a magnesium ion, and those are two iodide ions. And so the opposite charged ions are what hold this whole substance together. All right. So hopefully you see the difference. Ionic compounds, electrons are transferred, and they're made of ions, and they're held together through ionic bonding. Covalent compounds are made of molecules, and electrons are shared between the atoms, and what are called covalent bonds. So in our next lecture, we will take a closer look at several more ions. We'll talk about ions in a little bit more detail, and so stay tuned for that. Aloha.